All right. What's up, guys? My name is Louis. Whoops. I was part of the data analytics program, and for my final project, I used machine learning to make predictions on the NBA 2018-19 season. So we were just trying to predict whether a team would win or lose. I was kind of trying to hit above 60%, and we'll see where we got to. A little bit about me. Pretty simple slide. I like food. Healthy food is good. Fattening food is definitely way better. I like beer. IPAs are my favorite. I like lighter beers as well. And even though this is an NBA-oriented project, I don't know much about basketball. You won't catch me watching a basketball game at home. I'm really only watching major games or games when I'm at bars or restaurants with friends and stuff like that. So first task was for sure learn basketball. So I went to a website called Sports Chat Place where they have an article. It's an in-depth analysis for every single game in the 2018-19 season. So these writers also make a prediction on those games that they're writing an article on. And I just tried to see what are some key drivers that drive their predictions. So here on the right, this line says the Clippers are 7-3-1 at the spread, last 11 games playing on 1 day's rest. Basically, they put a lot of emphasis on fatigue. Teams are tired. They probably won't be playing too well. So I knew I wanted to add a time on the road feature to our model. Winning streaks are important. That last bottom line on the left says Portland Trailblazers have won each of their last 9 home games. Obviously, teams that are hot are going to keep winning, or they might keep winning. I thought the opposite might also be true. Losing streaks, basically, if teams are cold, they're not going to be performing too well either. So I wanted to throw that into the model. And then they also talk a lot about individual player stats. So top right, Steph Curry is averaging points, Kevin Durant is averaging 23, and Klay Thompson is also hitting those double digits. So basically, there's only 26 All-Stars in the NBA, and there's 30 teams. So these teams that do have more of these All-Stars might have an advantage. So I wanted to include that also into our model. And the coach rating, we'll talk a little bit about that later, but it's something I kind of made up. This is the original data set. It's kind of ugly. It has a lot of information that we don't need. Every single record is a game in the NBA. It's already ordered starting from the first game of the season all the way to the last game of the season. So I knew I could get rid of the date, fix some of the column names. For example, the visitors' points is named points, but the home's points is named points one. Just a couple of things to fix it so it'll be easier for me to read and keep working with for the rest of the project. So our our clean version of this data looked like this, just simple, the away team's name, the home team's name, and then we came up with this column from the scores, and it's basically saying what team won. If it's a 1, the home team won. If it's a 0, the away team won. So Renzo talked a little bit about train test split, and that's basically how we train our models and make predictions. So with this data alone, we probably wouldn't get too good of an accuracy score. So we want to incorporate those features that we were learning about from the Sports Chat Place articles. So this is kind of how that process works. After we add a brand new feature, which will be a new column in our data set, we're going to retrain our model using the first 80% of games in the season. That's 900 games. And then once it kind of gets an idea of different patterns and how variables are basically related to which team is winning or losing, we could use the last 20% of games, which is the last 300 games in the season, and make a prediction. These models, we're going to be using 3 models, a linear regression model, support vector, classifier, random forest. How they work, you guys don't really have to know, but basically they're all going to be giving predictions. And then we're going to compare those predictions to what actually happened on the last 20% of games in the NBA. So starting data, just with this alone, just the away team, the home team, and who won, the first model was at 67% accuracy, which is pretty good. Breaking out of this 67% range was really, really hard. We'll see that later. And the other 2 models didn't do as well. The second model was at 59% accuracy, and the last model was at 66%. So now we're going to start adding our features that we learned about in those articles. First feature was time away. Basically, this is how I tried to measure if a team was tired. Basically, the program, the script, goes through the away column, and it starts making a counter for every single team, every single time that it finds a team in the away side. So for example, Miami Heat are in the 5th row, so their time away is at 1 because they played one away game, and then they show up again in row 14, so their counter goes up again because they've kept playing on the road. They're probably a little bit more tired. When the program finds them in the home slot, it knocks their time away counter to 0, kind of means that they're refreshed. So this didn't do anything. It literally got our model like 0.5% up, our first one, and it didn't do anything to the other ones. So, I mean, it was a cute idea, I guess, but useless. So this is where we got some better results, the winning streaks. So we added these two new columns called the home winning streak and the away win streak. And the first model jumped up 2 points, 2%. The second model jumped up 12% to 71.5%, which is pretty good. And that third model got to 68.7. I thought losing streak might add some value to it, because if winning streak did, maybe cold teams might make a difference. So it actually made every single model worse. So at first I was like, okay, this is garbage. But I realized that keeping this feature in the data, at the end, it actually gave us a better result than taking it out and continuing our project. So, I mean, it's not that bad. So coach ratings, this was kind of a weird idea. I knew that some coaches could kind of turn a game around. Even if they have these monster teams, the coaches are important. So these coach rankings are something I got just from, I don't know, like NBA fanboys online making their ranking systems. So if you're the San Antonio Spurs, you get 6 points on your team. Boston Celtics get 5. Golden State Warriors get 4. Utah Jazz with Quinn Snyder as their coach get 3. Rockets get 2. Raptors get 1. And that was a new column in our data set. And our models went up a little bit. So we're at 71% in the middle model. And the last thing that we added was just the amount of all-stars that every team had. This was kind of the last thing we wanted to add. And it got us to 72% accuracy on the SVC model. So how good is 72.3%? This is the last slide. Comparing our results to some of the best sports bettors in the world, these guys are basic. This is from a website called VegasInsider.com. And some of their best sports bettors are at 57%. On another website, they're also at 57%. The thing is, we can give them a big benefit of the doubt that they're not just betting on whether a team wins or loses. They make really complex bets that pay out really well and are way harder to predict, such as spread bets. Basically, it's predicting whether a team will win or lose, but also in a certain margin of points, which is really tough. So do I think we could make money with 72% on win-loss? Maybe. I think it would work, but it's hard to tell. And that's it, pretty much.